Welcome to Command Shift Left, the podcast that helps you navigate the treacherous waters of the software development, ops, and security world while also diving into the hot current trends in the industry. Join myself, developer Philip, our co-host or Vice.
Hey audience!
As we battle through hilarious real-world stories, pro tips and hacks for navigating your way around developer security, learning about our Shift Left life, and life stories that have saved our ass. We're very honored to have two amazing guests with us today. We have Amir and Puneet. Thanks for being here with us. And as a short introduction, why don't you guys tell us a little bit about yourself? And maybe let's kick off with Amir.
Sure thing. My name is Amir, and I've been an engineer for the vast majority of my career, classically trained electrical engineer, with a focus in control systems, intelligence systems, that kind of jazz. But in more recent times, most folks know me due to my work at Cypress, the open source test automation technology and company, where I eventually led the developer experience engineering team. But these days, I'm an investor at Fire Streak Ventures, where I have the distinct pleasure of working with my partner, Walter Korchak, who is an amazing individual and a prolific investor of our era. And together we back early stage founders and companies who we think can be generational technologies in developer tools, AI systems, cybersecurity, and infrastructure. So this is what I enjoy doing now, and I've been having a blast. And I might add that we're also proud backers of Permit.
Yeah, we're very happy and lucky to have you.
Thanks for having us.
Amazing. Thanks, Amir. And how about you, Puneet? Tell us a little bit about yourself.
Yeah, sure thing. Nice to meet everybody. My name is Puneet Gupta. I'm the founder CEO of a company called Amberflow.io. I'm sure we'll have a chance to maybe talk a little bit about that, but let me just give some quick background. A little bit long in the tooth, been around for, coming up 25 years plus in tech. And I've been really lucky, have had a couple of good runs. I want to call out some time spent at AWS, Amazon Web Services, in the early days. Was there as a general manager with the team, launched Amazon Cloud Search, Amazon Open Search. So really just a profound experience. I had a chance to join them early 2011, so a lot of lessons learned from there. And then after that, I spent a few years at Oracle. When Oracle got serious about building their cloud infrastructure from the ground up, I was a founding member of the Oracle cloud infrastructure team. So been in the cloud. Started life as an engineer, first 10 years, 12 years, and then kind of transitioned into product management and kind of owning teams and building products. Amberflow.io, so this is a startup. Actually, we're coming up about 4 years in, venture-backed. And we saw a shift in the market. Just by ways of where I've been, perhaps I saw it a little bit earlier, where we felt that businesses are going to move to a model of usage-based pricing and billing, versus what's traditionally a seat-based or user-based license to more of a usage-based. So our company, Amberflow.io, provides a platform for businesses to shift to a usage-based pricing and billing.
That's awesome. And I think this would be a good point in our time to move to our first fact.
And I think the first fact is yours, so why don't you take it away?
Will do. So my fact for this episode is that a lot of engineers take watt per second as one of the most important metrics for good code or software. So watt per second, or what the fuck per second? In general, it's really hard to measure the quality of software to say if this is good or not. If you're doing code review for a fellow engineer or another project, or you're doing an open source project, it's really hard to say, is this a good project or not? And a good indicator for that is how many times you say what or what the fuck as you go through the code. And I think it's a really interesting and sophisticated metric. And I want to give here some classic example of what triggering examples from one of the most prolific elements of software today, JavaScript. So I'm going to give you a couple examples from JavaScript. Don't look at the notes. And I'll ask you, what do you think JavaScript will basically act on those operands? So if we try to concatenate two lists in JavaScript. So we have empty brackets plus empty brackets. What do you think JavaScript would output?
I think it's going to be something stupid.
You are correct.
An empty list.
So an empty list wouldn't be stupid. It would be actually kind of the right thing. Two empty arrays, two empty lists. You get still an empty list. But no, the answer is an empty string.
Hey, it's like brute force typecasting.
That's the essence of JavaScript. Let's try another one. So a empty list plus a empty hash map, empty curly braces.
Interesting. I don't know.
Well, let's start. Well, what do you think would be the right answer? Like, what would you think would be something you wouldn't say? What the fuck is this?
Man. I mean, the thing is everything in JavaScript is somewhat supposed to be, it's a prototypical language. Everything's kind of supposed to be an object. So, but that doesn't necessarily mean it's, I don't think you should yield an array, an empty array, or an empty object either. But something in that realm.
I think because you said it shouldn't yield an empty object, I'm going to place my bets on it yielding an empty object.
So that's kind of close.
Yes, I was going to vote on empty object too. I think it just, yeah.
You'd hope so. I think the right answer here should be an exception because these types shouldn't really play together. I think that would be the proper thing to do. But what JavaScript gives you is the string brackets, object, object, brackets.
Oh, the classic stringified.
Now, what if we change the order? So it's still an object or a hash map plus a list, but now the object comes first.
Oh, wow. So the order does matter here.
Is it going to be an empty string or something?
You'd hope. The answer is 0.
See, typecasting again.
Yeah, that's again. These are things that the only logical reaction is to say, "What?"
Are these things justifiable in any way? Like, has someone who did the syntax for this or did the logic for this?
I think in the future, when they take the authors of JavaScript to court, I wouldn't want to represent them. It's kind of a lost case. And the last one for dessert, object plus object, hash map plus hash map.
Two objects. An array of two objects.
So I would have accepted that. I would also accept an empty object, a new empty object. Even a reference to one of the objects is an empty object. But no, what you get is not a number, NaN.
Not a number, NaN.
Oh, the classic not a number. There is also other examples of JavaScript outputting not a number for very, very specific scenarios that have absolutely zero sense.
Yeah, and another interesting thing here that I think is worth kind of taking into consideration is the basic elements of backward compatibility. So we are working with JavaScript, and it's running our lives for quite a while now, and it's becoming more and more prolific. It's covering more areas. It's becoming more dominant in newer categories. It completely took over a front end, and it's getting into IoT devices, and it's getting into into back end as well with Node.js. We're carrying these decisions. These are decisions that were made quite a while back, and we're stuck with them. Because now if you change these definitions, it might change the behavior of code that is in some way maybe relying on these weird things, even without even knowing it. Like the developer kind of tested for this edge case and made his code work for it, and now it's just stuck there.
But maybe, I mean, just it's slightly in its defense, right? I think, and just to maybe been around the block for a long time, you got to wonder, okay, why was this possible in the first place, right? So I doubt, the designers of JavaScript actively, intentionally made it so open-ended. So there must have been some kind of a thesis of why this happened, and I don't know, but I would guess that, because in the early days the browsers were so varied, the DOM structure different across different browsers, it was helpful to have a little bit of a flexible typecasting so that as the new versions of browsers were coming around and everybody was kind of going their own direction and updating the DOM, it just didn't fall over every time, a new browser version was released.
That's a great point. I also do know that, the origins of JavaScript, it was made pretty quickly. I believe, the first incantations of it were over a weekend, the classic, weekend project. So, maybe I think it's probably an amalgamation of all these things where, we had the rising, tide of browsers and DOM implementations and people wanting to try to create this language overnight. We're left with these kind of historical artifacts of the language.
Yeah, we actually covered this in another Command Shift Left episode that focuses on the origins of JavaScript, like one fact, focuses on the origins of JavaScript. And there we talk about JavaScript basically being a scam. It was part of the kind of Mozilla project, and they, even its name, like it was originally named LiveScript and said, oh, we need to make this more popular. What's popular right now? Java. We'll call it JavaScript. Anyways, I think this is also a perfect time to move to our second fact. And I think that one belongs to you, Amir.
Sure thing. So my fact is really a broad reminder and probably a statement of the reality that most developers have felt. That's about testing. And that reality is that the vast majority of software that has been shipped and in production today is frankly untested. Testing is one of the classical controversial topics, in software development. Folks of kind of, I think every generation has had their opinions about it based off the context of the times, the tools that were available, and really how much compute power they could have to actually run some of these types of tests. And so, I think the problem of testing is still largely unsolved, despite the tooling that, we have now today, which is better than ever. But yeah, most software still goes untested. And, there's a lot of stats to back this up beyond just, I think most folks, lived experiences. And there was this interesting survey done by the folks at Sauce Labs, one of the better known testing companies. And one of the things that it revealed, and which I think is pretty relevant for our kind of GPT era, is that they found that 61% of the respondents to the survey said that, they have shipped code that they just copy pasted from ChatGPT, and totally shipped, totally untested, and about a quarter of them do it on a fairly regular basis as well. So I think this compounds the kind of the issues that have already existed, with folks now being able to craft and ship code that they didn't write or maybe are not familiar with it. So I think the tools of the trade, I think, have to have an answer for this and kind of grow with the style of development. As we got copilots, code generators, all sorts of things like that are now on the rise. It's interesting times. I mean, at Cypress, we were kind of at the forefront of some of this challenge. The historical kind of view of testing, I can kind of put it in maybe 3 phases now that have happened over time. At first, everything was manual. Actually, that wasn't that long ago. I remember even 5-6 years ago where, I was talking to one company in particular, and this would have been a classic modern, San Francisco startup effectively. And I asked the CTO, how does your testing look like today? Well, they said, well, every week we take out a Word document, we write down our test cases, we ship it overseas, and hopefully in the morning we'll get a spreadsheet of the results. And that's fair. The industry's had to do that kind of stuff over time, and there's an entire industry built around this. But of course, it's somewhat shocking to hear, in more recent era, and especially as if you're working on a testing tool. So manual testing, was broadly leveraged and still heavily in use today. Then we kind of shifted over to automation, and I think it's interesting that this podcast is named Shift Left, and the basis of test automation really was around this concept of shifting left, at least in the last half decade or so, where it's okay, hey, we can test earlier, the developers should be in charge of their code, so on and so forth. And during that era, I saw, folks, approach me and say, hey, I've been doing this manual type of testing. It's been my career. There's all this knowledge, that I've built up over the years, but I kind of see the rise of automation coming for my job. What can I do? And so, it was kind of sometimes emotional conversations for some of these folks, and it was great to actually have an answer. But this whole vast workforce kind of need to be updated and trained on automation technologies, and a lot of folks did do that. But now we're entering a new era, I would say, where, more and more folks are testing, which is great. We're building more complex and higher quality software due to that. But the thing that we have to toil with now is, we're going to be dealing with a lot of code that we didn't write, and we didn't architect, or we didn't get to think through, or we don't really get to mess around with, so we can build these experiences over time. And so, I think the next generation of testing tools need to kind of built with a complete consideration for this new kind of state of affairs. And I've seen some new companies and tools that are kind of attacking this problem head on. But I'm excited to see what else is there to come.
I don't know what it is with testing, and I had my fair share of it when I joined Cisco first, because when I joined Cisco for the first time, I was actually on the testing team. And I don't think I know anyone who actually loves to write tests, nor maybe just likes writing tests. I think everyone kind of treats it as a almost some kind of maybe punishment if you're an engineer, because everyone wants to work on the creative stuff, and then all you do with tests is you come forth and you have to test someone else's creative work in some way or another. And then it's interesting you mentioned the generated code, because now if people are using code generators to write tests, for example, then those tests have to be tested, right? I guess in some way, because we can't have full trust into what the AI kind of brings us. So it's the tests for the tests. So are we going to come up with new tools for testing? Are we going to kind of restrict using code generators for writing tests? It's a bit of a difficult one if we're looking into the future, right?
Yeah, it's actually even more recursive than that, because think about like the main tool people use for generating code today, like ChatGPT or Copilot. These machine learning agents are trained on examples of code. So you basically you take GitHub, you take Stack Overflow, and you push them into this agent to train them, and then it generates code. And then someone shares that code on GitHub and Stack Overflow, and now you have like this vicious cycle of code. And maybe it's also like there's a chance that we'll be diluting the quality of our code, or at least the quality of our tests and the quality of the code that we share with one another. And this kind of triggers me. Another thing that triggers me here is that as an engineer myself, I kind of maybe have somewhat of a Soviet mentality, maybe from my army service, but like I firmly believe that a good engineer needs to write their own tests.
Yeah.
Like if you delegate your testing to someone else, like you're basically not taking the full responsibility. But I might be too strict here.
Also, wouldn't it be easier for someone to write their own tests because they know what they're writing tests for? Like more efficient?
So there's pros and cons here. You have different philosophies. Someone would say that actually someone coming in with a blank slate, like clean eyes, not invested in the code, will be less biased and will look for more scenarios that you might like. There's the joke of like a tester comes into an app of a bar. He orders a drink, he throws the drink on the floor, he orders 5 drinks, everything's okay. Then an actual customer comes in, goes into the bathroom, and the entire bar sparks into flames. So you actually need a different mindset to find the bugs that you don't think about.
Yeah.
I think I have a really funny story on testing to share. This is a real deal.
Mm-hmm.
But it myself, this almost like 15 years back. This was a large database company in the Bay Area. And, that's just to put the right context, we're talking like yearly release cycles, right? Big monolithic releases,
Mm-hmm.
big thing.
The spirits of the time.
Yeah, exactly. It's a classic QA team. And of course, company was anxious to kind of get the product out. It was getting delayed. in QA testing and back and forth. So one of the VPs, in the spirit to kind of get this thing finally done to the finish line, say, okay, we're going to put an incentive plan in place for every bug that the QA team finds. It'll be $100.
Oh, I can already see where this is going.
Exactly. Then just the rate of bugs started to increase. Then there was collusion between engineers and the QA folks.
Yeah.
So I'm sure this is maybe too common, or I don't know, but back then this was a real story.
Yeah, this is something that also happened in history. I don't remember I think it was in India that the British, they had an issue with rats, so they created a law that everyone that brings in a dead rat gets payment for it. So people just started farming rats so they can, and so it
Right.
made the problem even worse. So it's exactly the same thing.
The thing is, like, you could actually do an entire podcast show on funny testing scenarios. You kind of hear them all the time, and I bet if someone collected them, they could totally do a show on it. Another funny one to add, which I think a lot of people will get a kick out of, there was actually a point in time where in Amazon, you could set the quantity field to be negative, which at that point, Amazon will owe you money. There's a good list from them, and I think I found like one book years ago that had compiled some of these stories of the time. But I think to maybe wrap up this fact, or I totally agree with you on this, where it's like it's ultimately the job of the developer to maintain and understand and support the code that they ship. Of course, it's always a team effort to an extent, but if you're writing it completely under the belief that you have to be able to support it, and if you weren't on that mind before, I think you should be moving forward, as I think companies are trying to get more efficiency out of every individual within the company. And I think to an extent, as an engineer, like I think having kind of pride in your work, you want to ship quality stuff. So why not write tests? And I always told developers that you shouldn't see tests as like this additional chore that you have to do, but it's something if you kind of put in the effort and learn it a bit more, which I know is like sometimes a tall order based off everything else folks have to learn, is you can actually not only become a better programmer, but you can actually develop faster, which is a key component to this. I think developers undervalue how much time they waste messing up and trying to fix it in weird ways, which of course debugging is a whole other topic on I think people are largely also lack knowledge on doing that too, which I think we need to improve. But yeah, totally. It's not a chore. It's something that could actually be additive if you kind of put in the effort.
Yeah, I think at the end of the day, it's a question of balance. Like you can also take it to the other extreme with like test-driven design, where you do the test first. I also heard a funny joke about that. Like the most important thing about test-driven design is, one, you need to write tests first. The second thing is you need to tell everyone that you're doing test-driven design.
The funny thing is, when you're saying you need to tell everybody, what I found is that sometimes it just takes one or two engineers in a company to start committing tests to the code base, and then one engineer is like, wait a second, what is that? For the ones that haven't done it before. We saw this all the time at Cypress, where one lone wolf would just start writing the tests and they would just commit it. And they were like, no, guys, don't worry about it. It's just mine. We'll just keep it in there. All cool. We don't even need CI for it. I'm just having it for me. And they're like, well, wait a second. What is that thing? And then they will try to run the script for it. And then they'll unlock this whole new world. And that's how it really kind of grew and transpired.
Spot on.
Amazing. And I think this is the perfect time to kind of jump onto our third fact. And our first fact is by Puneet. Puneet, take it away.
Very cool. So my fact is, I think along the lines of, I will justify also in the spirit of shift left. And that is that one of the biggest hidden secrets, and therefore a very often overlooked aspect of developer lifecycle DevOps, is not monitoring, but metering. So yeah, let me unpack that a little bit and see what you guys might think. Yeah. So just by the name, it is a close cousin of an event-based system. So event-based systems, obviously we're all familiar with monitoring, observability, logging, right? Classic event-based systems. And I think you can all argue that they all also help to kind of shift left, because these are tools that you put in place early in the cycle. Metering perhaps is less talked about, but I will claim that in the world of cloud native, as more and more companies are becoming, this is probably even more profound and more valuable from all sides compared to the traditional logging, observability, and monitoring. So what is the high level distinction? Okay, what is metering? How's metering different from monitoring, let's just say? Okay. They sound similar. I also said, okay, they're also an ingestion stream. Here's the thing. And again, this is leaning back on a lesson learned from time at AWS, building a couple of services there. If you want to be cloud native, right, which then basically means that you are adhering to or aspire to be operating on cloud first principles, which then further means, cloud first principles basically means that you are operating on the foundation of elasticity. That is a principle. Resources can be dialed up, resources can be dialed down on demand. That is because of what we call cloud computing today. And I would say that, what you and I refer to in parlance cloud computing is really elastic computing. I mean, cloud is a euphemism that we have given to elasticity. But elasticity is basically what's at the core of cloud computing. So the question then you have to ask is, in the spirit of shifting left, monitoring, tracking, what is the tool that helps you usage instrument, what is being used, by whom, when, where, how much? And if you are not doing that, then my friend, my thesis is you are essentially flying blind. Okay, you are not cloud native, because if you are not getting ahead of elasticity, I like to say it, we used to say it at AWS, if you are not taming elasticity, and elasticity is driving you versus you driving elasticity versus you controlling elasticity, you are essentially flying blind. And the measure, track, instrument, stay ahead of elasticity is not monitoring, it's not observability, it's metering. And the technical distinction then between monitoring and metering, or observability and metering, is metering has attribution. On whose behalf is this thing being consumed? Resource attribution, system attribution, application attribution, cluster attribution. Where monitoring, as you would agree, primarily is function, source code attribution. Right? That's monitoring. That's observability is, how hot are you running? How cold are you running? Metering is who is using you? On whose behalf are you running? And for how long have you been? And who has used you for how long and how much and where? And that is metering. So this is, I have found, I think it's a little bit of a hidden secret, not well known. It certainly was a eye-opener for me. When I came to AWS, I wasn't aware of this, but I can tell you that the backbone for business operations, for a cloud-native business, is metering, cloud metering service.
Yeah, absolutely. Man, I mean, we're recent backers of a company that focuses on this, and I found their product, very interesting. It was basically everything you're saying. This metering aspect is super important, and you want to limit, for example, new engineer that's trying to figure things out, spend new resources up. It's like they shouldn't be able to kind of spin up too many resources, like high RAM instances or anything like that. And they've kind of built this product to tame it and put boundaries and guardrails, so you can have that attribution, and then also have an understanding of who's doing what's being leveraged, because the costs actually go crazy when you don't have this metering component in place.
Yeah.
Mm-hmm.
Yeah. So, and exactly, Amir, right? And then, okay, so now let's play this forward. Okay. So that's the structure. That's kind of the technical details. Okay, this is what it is right now. Yes. So when I say you're essentially flying blind if you don't have metering. And the thing is, it's not a dig at anybody. I mean, people are doing all kinds of different things, but you probably end up with some kind of a mishmash of different things, and you may get there, but you're not going to quite get there because you're not guaranteed accuracy, all those things. Metering gives you that, right? It says item potency built in, data deduplication built in. But yes, cost attribution is a natural extension that falls out of metering. I'll give you again a direct example of this, right? And by the way, as you can see, and where this leads to, so this is really that foundational layer for cloud native companies. We talk about we enable pricing and billing. Guess what? And Amir, same thing, right? We first and foremost offer a horizontal platform-oriented metering service. We call it the Metering Cloud. Metering Cloud is the foundational horizontal platform, and now we can stand up applications on top of this usage graph, right? Metering service. One of the things that and people like this, so I'll share this. I found when I used to describe that there's a whole space out there on this cloud cost management space. I think that's kind of what you were talking about, right? It's important. You want to contain costs. It's because it's elastic. It can quickly get out of control. So, how do you keep track of your cloud costs? And there's a plethora of vendors out there that give you quote unquote cloud cost management tools. I'll share with you how we used to do it at AWS. Okay, and it's again slightly different perhaps than that is how most of the companies are doing. So I was a GM for a couple of services, and I say that just because I think people are generally aware AWS is maniacal about cost control, cost optimization, as any company would do. So at the year, and we had to come to the table with how we plan to take cost out of operations, how we want to become more cost efficient, right? And I can categorically tell you, I didn't used to sit there, wait for my AWS bill to show up to figure out how I'm going to contain cost or optimize cost or save costs. So, no secret, the tool we used to use is the metering service. We used to basically meter our own usage of cloud resources before the AWS bill, right? So I didn't need to wait for the AWS bill to show up to see what was being used. We had the metering dashboard that sat ahead of the bill. And the irony is, if you think about it for a second, everybody has seen, or, if you're running on any one of these cloud providers, I just keep referencing AWS because, I've been there, but, all others are kind of the same too. Ask the question, how is AWS generating this bill for you? Wouldn't you rather also have that same infrastructure for yourself? The AWS bill comes to you as an output of the metering service that AWS has. So this is, I think, an area I feel companies are sort of starting to realize, and maybe even worth talking about. So why has it gone on as a hidden secret or overlooked for this long? And again, I don't have the answer to it, but I think one of the reasons is that the business model was not there, was not dictating the need for it, right? So AWS, all these cloud providers by default are on a usage-based model. They cannot operate a single minute without the metering service. The deck will just come crashing down. So if you didn't have a usage-based pricing and billing model to go forward, then maybe you didn't have the need for usage instrumentation. I think maybe that's one of the reasons why it's not part of standard IT stack.
Yeah, I think you're touching on really critical points. I also like the shift left aspect of it. You were essentially saying the understanding of the intent of the software and the business needs to also shift left to the developers. If you're a developer, you're building something, you don't need just to understand the different gears. You need to understand what these gears do and what they are doing it for. What are these gears connected to as overall? I think this is an important sign also in where are we going as engineers? As the complexity continues to rise, as we have more automation, as we have more machine learning agents baking into our software, where are we supposed to progress as engineers? And I think shifting left into understanding the business as a whole is a very natural direction to go through. And I also want to kind of do a callback to another Command Shift Left episode. We talked about metering in the sense of not your financial budget with AWS, but your ecological budget, your basically your carbon budget. So this is also a feature that AWS has. It tells you what's your application's carbon footprint, and it's also something that is being metered and is quite interesting and becoming important also from compliance factors. So for our listeners, if you want more of this kind of thinking on metering, you already have it in Command Shift Left. Just go and listen to a previous episode.
Also, I think there's also a point to be made about, you mentioned that like the business model probably didn't exist for some of the tooling to exist to help out with this. You mentioned cost optimization companies, and I think you really got to see the rise of them right around the same time. A lot of companies had to really tighten their belts and kind of reduce kind of like free-form spending on infrastructure. Had to really tame it in. So I think now we're in an era where these tools are really valuable and there can be a business model for them.
Yeah, and I think, just what we are seeing, I think this whole generative AI, LLM, and I think other forms of AI, ML that's we're probably going to see coming down the pipe, I think yet another sort of catalyst that is further, is now generating awareness that you need this. And I think, as you were saying, you see my view, the whole concept of shift left is, this is an engineering exercise. There's also a lesson learned from my time at AWS. In the old world, perhaps cost optimization was off to some team to the side, at the end of the month, end of the quarter, year, whatever. This is squarely a product and engineering function going forward. And it doesn't only have to be the developer tools like, observability monitoring. We have just a Datadog dashboard for the engineering team. Now this says engineering product needs to own it. What is being used by whom, when, where, how much, independent of what you do. If you're running in the cloud, you got to have those dashboards in front of you.
So people listening to this episode, you now need to decide, are you going to add more tests first or more metering first? Or I'll let you think about it. But while you think about it, we'll use this as a perfect stepping stone and leapfrog to our final fact for this episode, our fourth fact, which belongs to Philip.
All right, so my fact for this episode is that the quantum computer called D-Wave 2000Q, I know, very science fiction-like, which was built in 2017, has a processing capability of 2000 qubits. Now, for those that don't know, a qubit or a quantum bit, it's the basic unit of quantum information in quantum computing. Now, we as engineers, we're all familiar with the concepts of bits in computing, ones and zeros, which are kind of the fundamental units of digital data. And of course, each bit can have a one, be in a state at each time. So it can either be a 0 or it can be a 1, which is the backbone of the way we manage and the way computing works as we know it of today. Now, a qubit is very interesting because it's very different to the ones and zeros we know. It can actually exist in multiple states simultaneously. Now, this is thanks to a phenomenon which is called superposition. And basically what this allows quantum computers to do is to process an extremely large amount of information at once, which technically could solve much more complex problems than we know our traditional computers could. So things like the language models that are, I think, running not on quantum computers, but just on normal machines, quantum computers can do probably much more than that. Now, for example, to give you a comparison of how this works, a normal kind of conventional computer could take 1,000 years to complete a task that a quantum computer could just do in a few minutes or seconds. So you can see the comparison here. It's extremely, extremely significant. Now, I kind of want to diverge this fact and talk about a little bit about cybersecurity, because I think quantum computers like the D-Wave that I've just mentioned, they could potentially break specific encryption methods that we have in cybersecurity now, because of the amount of and the vast amount of power that they have. Technically, they could have the possibility of breaking things that we've written, which we thought were extremely secure. So my question kind of stands is, do you guys think that this is something that maybe we should be worried about in the future? And maybe if quantum computers become accessible, because at one point they probably will we have to kind of re-engineer the way we work with software and how we kind of go about writing security measures for the applications or hardware that we work with?
So I'll give you two angles on this. So on one angle, I'll tell you don't need to worry about this at all. Also for two reasons. One, we already have quantum safe cryptographic solutions. We already have algorithms that are safe, that classic computers can work with against quantum computers. So we got that covered. And also, we're, at least what's on the surface, we're so far away from actually having a quantum computing that is worthwhile. Like we're now, I think you mentioned 2,000 qubits. I think now the max is around 5,000. IBM is looking at having like 10,000. But still, in these figures, these computers they're conceptually interesting, but they can't do anything. Any compute that is more significant than your classic computer. So this is mostly kind of just a show or a gimmick. It's.
But they can do it faster, right? If they can do it so much faster, they can go for more.
They can technically do it faster, but it's still the amount of the volume that they have. It's still slower. So conceptually, when you get to tens of thousands, hundreds of thousands of qubits, it can actually take effect. The scale that we have now, it's only theoretical.
Mm-hmm.
So from that front, you don't need to worry at all. This is not going to change anything. But here I'm going to give you a twist, so you will have some concerns as you go to sleep. So as we know, the world is obviously dominated by the lizard people and the Illuminati and others. But there are actually some things that happen in history that are to that effect. So the back in the 70s and 80s, the NSA, the entire world worked with an algorithm for encryption called DES. And the NSA were like, yeah, this is a good algorithm. You should use it. While they already had a way to crack it, and they could easily decipher any message encrypted with DES. But by the way, I worked a bit with the NSA, and they have an internal conflict. The NSA is both responsible for producing cybersecurity offensive capabilities to be able to obtain intelligence. They're also responsible for alerting everyone within the U.S. economy, at least when there's vulnerabilities that they need to patch against. So here they kind of towed the line. They decided not to share this with the world. So the entire world thought that this is a worthwhile encryption algorithm, while for the NSA it meant that basically nothing is encrypted for them. So we might be in this situation as well. Maybe the NSA or some other government entity, maybe the Chinese, maybe they already have stronger quantum computers and they're reading all of our messages and laughing as they run their business. So it can go either way, but I'm still leaning towards you have nothing to worry about.
Yeah, this is like a lot of parallels to what's going on in the AI realm today, where there's a lot of concerns about safety and responsibility around this stuff. But yeah, we got thankfully we have those quantum kind of protected encryption algorithms, which is great. But I think as this thing probably gets developed, we should be super conscious of like how to defend against it, because even though we have these cryptographically quantum safe algorithms, we still have a lot of not those algorithms deployed. So hopefully whenever the hardware and the systems come together and like people can actually start to use this, hopefully we do it in a responsible way where it's not just like unleashed to the world. And I particularly don't have that concern because unlike AI, where it's like anyone can start training stuff, technically speaking. Quantum is like you need massive investment. You either need to be at Google or you need to be like a state sponsored project or something. So I will put my faith in humanity on this one to kind of do the right
Those
thing.
Guys, really?
It's all I got, man. It's all I got.
What are just curious? and so, or you picked on 5G. Okay, we're not there yet, right? But is there anything on the horizon? Like, when is that inflection point where it is going to cross into that threshold, as Philip, as you're saying, that it can really be orders of magnitude more efficient? Right? Is there anything like? Do we have any visibility into that? Because we've been hearing about.
Not really.
Curious, like, is it?
We also don't know if it's feasible. Like the entire. So you can create potential a lot of qubits. The problem is basically having them within the same circuit in a computer, so they can either be in superposition or entangled. And we don't actually know. Our physics theory doesn't really tell us if this is doable or not. If the fundamentals of the universe allow.
But it's kind of like, what I can think of is like 30 years ago, we didn't know that a smartphone is going to be something that we use most of our day, that literally runs our life. Nobody ever imagined it even. So it's the case that, we might think that it might not happen ever. Maybe it's very implausible, but I think there's still that tiny chance that something might happen, that, things go in one direction and suddenly we are controlled by quantum computers.
Well, technically, Star Trek did imagine it, so I'm assuming they might have imagined some of this quantum stuff too. Yeah, they did.
Yeah, we just need to look into the Simpsons episodes, because supposedly they predict the future. See if quantum computing, appeared in any of those.
Quantum computer.
You know how they predict the future, though? They have a quantum computer that enables them to compute all the options. And also, Philip, I'm sorry to have to tell you this, but as with every Command Shift Lab episode, we have to reach this point at some part of the episode, and I have to tell you, this is entirely a simulation running in a quantum computer. It's just for you. It's basically the Philip show.
I think this will be the perfect moment to wrap up the episode. So, Puneet, Amir, thank you so much for joining us. Thank you so much, guys, for your time. We appreciate you being here. And as always, we will see you, to all the listeners. We will see you in the next episode.
All right. Thanks, guys.
Bye, everyone.
I think this is the perfect time to wrap up the show. If you liked this podcast, tell your friends about it. If you didn't like it, tell your enemies about it.